was the 0.24 the midpoint of a segment that had -3.5 for one endpoint and 7.3 for the other endpoint? And I saw varying answers from your homework, and we'll come back to that here in a second, but the question really comes down to, all right, well, how do we find the coordinates of a midpoint? And sometimes we can do it from the graph, but other times we're going to have a different way of trying to attack that. So before I answer that question, what if I asked you this question? If I said, okay, what's the median of this set of data? Well, you may or may not remember the median is the middle number, the middle value. And you may have learned to start at the low end, mark off the high end, and keep going until you get to the middle. But do you remember what you would do if you got to this case where you actually had two numbers in the middle? Do you remember? Yeah, add them up and divide by 2. So in this case, I'd have 17 divided by 2, or we'd have 8.5 as our median. Well, we're going to use that same idea to help us find our midpoint, because the midpoint is really what's in between these two, in this case, points. So going back to this problem here, I can find the midpoint by, first of all, looking at the x values and doing exactly what we did here. So I'm going to take the first x, which was -3, plus the second x, which was 7, and I'm going to divide by 2. So I have 4 divided by 2, or the x value should have been 2. So far, so good. Then I go to the y values, add them together, and then divide by 2. So in this case, 8 divided by 2 is 4. And so in answering their question, yeah, that was the midpoint. Because if I add the two x's together and divide by 2, that gets me the x coordinate. If I add the two y's together and divide by 2, it gives me the y coordinate. And that's how we're going to find the midpoint if I know the two endpoints. Some of the problems you may see, and it may look like this, it may say, okay, find the midpoint of a certain segment when you know the two endpoints. We know one of them is at -2.8. We know the other one's at -5.2. We'll find that midpoint again. It's just as simple as taking the x's, adding them together, dividing them by 2. So what are my x values on this one? -2 and -5. Divided by 2, and that'll give me my x coordinate. So this one, yeah, would be -3.5. And then I turn around and do the exact same thing with the y's. So I'm going to take the 8 and the 2, add them together, divide by 2. And so I find out that the coordinates of the midpoint here would be at -3.5. Sometimes where it gets maybe a little bit trickier, a little bit confusing, might be a problem like this, where they want us to find the coordinates of A. They say that the midpoint is M, and they actually give me the midpoint this time. And then they give me the coordinates of B. So kind of picturing what they're saying you've got this segment AB. We've got this point here of M. I want to know what the coordinates of A are if I already know what the coordinates of M and B are. So somehow I got to figure out, okay, what are the coordinates of A? Ideas on how you might want to attack something like that? What's if? So give me some numbers to work with on this. And then you said times 2? Okay, let's test it out. If I did that, I'm going to have, what, 2 times 2 or 4? So if that works out, I should be able to add, this is the x value. I should be able to add the 4 to the -3. So that would be 1, and divide it by 2. And that should give me the midpoint. Does that work out? Not quite, right? So I think we need to approach it a little differently. Other ideas of what we might do with them?
You could take 5 times 2, and then do 8 times 2.
Are you trying to find X or are you trying to find Y here? So I think you put them both together. Now, I like this idea of multiplying by 2, but we got to figure out what it is we're going to multiply by 2. Other ideas? You have an idea?
Can you find the difference between the M and B, and then use that difference in the A and M?
Okay, why would we want to do that?
It's the midpoint, so equal on both sides.
All right, that's a good strategy. I know that from M to B should be the same as it is from A to M. So if I can figure out how far it is from, say, here to here, it should be the same distance over here. So if I start at -3, because that was on the end, what would I do to -3 to end up with 5? Plus how much? If I start at -3 and I end up with 5, how much did I have? 8. Which means if it's really in the middle, I should be able to add 8 again and get to the other endpoint. So if I add 8 to that 5, I get 13. Now let's look at the y's. How do I get from -8 to +8? Add 16, which means I have to do the exact same thing to get to here. And so if I add 16 to 8, I get 24. So that might be a good way to do it. Thinking about, okay, it's really got to be the same distance. I think what some of you are trying to do there, which was a good strategy as far as the multiply by 2 part, something else you could think about is, all right, this is X, I'm missing it. I know when I add the other X value of -3, and then I divide by 2, I should get the X coordinate of 5. So to solve that, I would have to multiply by 2, and that's where that came in. And then I'd have to add 3. So 3 plus 10 gives me the 13 that we got there. So that was another strategy you could use as well. All right, so you'll start seeing some of these pop up, and actually we're going to do something with midpoints today, where mainly we're going to use this first type, where we add them together and divide by 2. But there may be some like that second one that pop up from time to time. So here's what we're going to do today. I'm going to give you a half sheet of paper. When you get your half sheet of paper, I'd like you to make a triangle or draw a triangle on that half sheet. Try to use straight edge if possible. The edge of your book or the edge of your paper. I don't care what kind of triangle you make, but make it fairly large. Make it most of that paper.
Yeah.
So make a triangle. Again, I don't care. It can be isosceles. It can be equilateral. It can be right. It doesn't matter what kind of triangle it is. It's some sort of triangle. Once you've made your triangle, I want you to find the midpoint of each side. So you can do that different ways. You can measure it if you wanted to. If you want to fold it, you can. But somehow I want you to identify where the midpoint is on each side.
Straight or good?
Whatever allows you to get to the midpoint. I usually think centimeters is easier. Did everybody get it straight edge?
Sure.
Once you've found all your midpoints, you're now going to connect the midpoints like I have up here. All right, once you've connected all those, I want you to cut out the triangles, okay? So you're going to cut out, you're going to end up with 4 triangles there.
So I don't have to. How about it more down?
Once you cut out all your triangles, go ahead and answer question number 1 on the sheet that I just handed out. I want you to see what you noticed about all 4 of those triangles that you just cut out.
Instead of bigger.
So what did you find out what was true about them? Yeah, they're all the same. They're all been congruent to each other, okay? Well, here's what we're really doing. First of all, whenever we connect two midpoints to one another, we're creating what's called a mid-segment, or sometimes it's called a midline. But a mid-segment essentially is just going to connect one midpoint of a figure to another point of a figure. What we want to look at though is, all right, well, what's special about that? Well, you guys are right. All four of these triangles were all the same. So if they're really all the same, we know all the sides should be the same and all the angles should be the same. So notice I have some markings here on the triangle, and it's the same as the markings on your paper at the bottom. But I know this segment and this segment are the same because we said that was the midpoint. Same deal here. These two are the same. That's the midpoint, and so on. But if all the triangles are the same, that means they should all have the same length side. Well, if this triangle has a marking of 1 and a marking of 3, this one has a marking of 1 and 2. What's that mean this side right here would have to have as far as markings? 2. It's got to have at least 2, right? Okay. And then over here we had 1 and 2, so I need a 3 here. And finally these had 2 and 3, so that had to be 1. That way everybody, or all the triangles had the same thing. All right, well, let's see what that tells us. Down at the bottom, they asked this question. They said on number 3, well, how does the length of DF, that mid segment that we drew, how does it compare to the length of AB? I labeled mine differently. No, it is, you're right. I labeled this differently than they put B down here. But you're right, DF is going to be half of AB. What about EF? How does that compare to AC? Half as long as well. And if we go to the third side, we find out the same thing. DE is half of EC. So whenever we draw the mid segment, one thing that's going to happen is that mid segment will have a length that is half as long as that other side, that third side. That's one important fact, and we'll summarize it here in a second. All right, if you look on the back side, we'll see what the other important fact is going to be. Well, it says on number 7 there that all 4 of the triangles were congruent. So what's that tell me about angle 1 and angle 2? Well, here's angle 1, here's angle 2. Well, angle 1 and angle 2 are both in between the 1 marker and the 3 marker, so that means they should have the same measure. So there on the back side where it asks on number 7, how does 1 compare to 2? We know they're equal to each other. So that leads us to number 8. And it asks, okay, what about DF and AB? Are they parallel? Well, if angle 1 and angle 2 are the same, that means these two lines had to be parallel. So DF not only is half as long as AB, but it's also parallel to AB. So here's what we need to remember about the mid segment. This is number 9. This is the key point. Number 9 says each mid segment of a triangle has two things that happen. The first one says is blank to the third side, and finally blank is long. Well, that first blank should be is parallel to the third side. And it's half as long. And that's the major idea that we're going to use for mid-segments. Anytime I connect two midpoints together, that segment we create is half as long as the third side in the triangle, and it's also parallel to that third side in the triangle. All right, let's see how we might use it. That first question wants to know, in that picture, what's the perimeter of triangle TOP? So they want to know what's the perimeter of this triangle right here. Well, notice some things that are marked on there already. They marked that this segment and this segment were the same. So that tells me P is the midpoint. They marked that this segment and this segment were the same. So that tells me O is the midpoint. So that means PO is actually a mid-segment. So if PO is a mid-segment, how long should PO be? 10, because it should be half as long as this side. The other two sides of that triangle we already know because they said this is 8, which means this is 8. They said that was 10, which makes this 10. And so now we can find the perimeter. So the perimeter of this one ends up being 28. All right, let's see what we might do on number 11. Notice the same setup. This time they drew in more than just one mid-segment, but we know all these triangles are congruent, just like they were earlier. Which means this would have to have 1, this would have to have 3, that would have to have 2. They gave us some information. They said this angle up here was 65 degrees. They said this angle down here was 42 degrees. Eventually, we want to find this angle right here that was missing. Well, the 65 degrees was in between a segment that was marked with 1 and a segment that was marked with 2. So if I go to this triangle here, that should happen again. In between the segment of 1 and the segment of 2 should be 65. And notice that's what we were missing. So right away I can figure out that Z is 65 degrees. All right, why don't you guys try 12 and 13? See if you can find X and Y on 12, the perimeter of TEN on 13. That first one uses the parallel lines idea, so what would be the angle measure for angle F? Yeah, it should be 60, it's corresponding, so it's in the same spot. What about Y? 140, because it has to be separated. Okay, so no new rules there as far as parallel lines, it's just we got to identify where that parallel line is. Then on number 13, they want to know that perimeter on the inside. There's a couple ways we can do it, but let's think about the fact that we're going to have half as long as this. So can you tell me the three sides there, Dan?
8, 6, and 9.
Okay, so this one would have been 9 because this entire side was 18. Which one was 8?
8 would be the one on the left.
Okay, so TE is 8, so that's half as long as this 16. And our last side, you said was 6. Okay, so what was your perimeter now?
23.
23. All right, so hopefully not too tough there when we look at the triangle. It's half as long as the third side, it's parallel to the third side. All right, one little extension because mid-segments can exist in other figures too. The one we're going to look at the most would be with trapezoids. So notice they drew a mid-segment. Let's see what's true about it. Well, does it look like it's still parallel? Yeah. So it's still going to be parallel, just like before. The part that's a little different is it's not just half of one side, it's now half of two sides. Because we've got two bases for our trapezoid. So let's start out with figuring out how long this side is. Well, to figure out how long it is, I'm going to take half of the two sides, add it together. So I'm going to add the two bases together, and then when I take half of it, that's how long that mid-segment would be. So in this case, it would be 30. Is that right? 42. Oh, I'm sorry. Okay, so we've got 84, so half of that's going to be 42. Angle-wise, we're back to the parallel lines.
I was going to say that for P, I did it a different way.
So what did you do?
I did 48 plus 36 divided by 2.
Okay, so the same as taking half of it. All right, so when we do N, what was the measure of N? 73. M, 129, because they're still supplementary. All right, 15 is a slight difference, but it's still the same idea. This time we knew the mid-segment, but we're missing one of the bases. So to find that, we're going back to the fact that I'm going to take the two bases and add them together. I'm going to take half of them and divide by 2, and I'm going to end up with the mid-segment. So really, I'd be thinking about this equation. So to solve that, I'm going to do just the opposite stuff. I'm going to multiply by 2, and I'm going to subtract 13. So I find out that Q has the length of 35. So the idea of mid-segments hopefully isn't too bad. It's just the fact that it's parallel and it's half as long. It's just a matter of it's half as long of what. In a triangle, it's half of one base. In a trapezoid, it's half of the two bases added together. All right, so at the time we have left here, two things that I'm going to have you focus on. One is the book problems that I gave you yesterday. The second is now some practice with the mid-segments. So both of these will be due tomorrow. But you got the rest of the time now to work on them. Yeah, you can go ahead and put it in the box there. So you won't need the scissors or the rulers anymore. Also, your triangles, you can recycle those.
And do you ever play rope? You only have one game. You ever play rope?
We're really gonna try to find out that essentially when you did that, you know, this rectangle, I mean, this rectangle. You know, this is 50, and you know, this is 60. The question is basically, from either park from a certain distance from this end or a certain distance from that. I know I'm gonna park here, so it doesn't matter which direction you went, it's slightly different answers. Let's say I wanted to figure out how far away from this. I said from here to here, I think was 80. So if this were all 80, but this was X, what's going to happen? I don't think we're totally right. But say this was 10. Right. Yeah, so that's how long this is. So here's where you can find that. This corresponds to that. This corresponds to that. And now we can do a personal point. Okay, use this time here. Your goal really should be to be done with both of them before you leave.
Is it a half times
Yeah.
16 or less?
There is a backside to that worksheet as well.
Oh, shoot. That's not right.
No.
Are you sure it's a half?
Yes.
Yes.
And then
Right
do you
there.
divide by 2?
Who was gone? Me? Is it me?
What are you looking at?
So is it